Oh, please.
We have rubber bond, we have silicate bond,
Absolutely.
and we have shellac bond, and we have resinoid bond. Okay, so now we can see that vitrified bond is represented by the letter V, rubber bond is represented by the letter R, silicate bond is represented by the letter S, shellac bond is represented as the letter E, and resinoid bond is represented as the letter B. Okay, so first of all, let me strike the case of vitrified bond, or what we can call as V bond. So this letter V comes from letter V comes from the word vitrified, and there is a Latin word which is named as vitrium. Now this vitrium means glass-like, shishe ke jaisa. Right. So what happens here is that we take clay and we take feldspar and we heat them together. We heat them together at a very high degree of Celsius, that is 1280 degrees Celsius. And then after heating up to a high temperature, we immediately cool it down. So when we cool it down, what
Okay,
happens?
fine.
We get a hard, brittle, glass-like bond. So this process is actually known as vitrification. This process is known as vitrification. So what happens? Clay and feldspar, they are heated together along with the abrasive sterling, and then after heating up to a high degree of temperature, then suddenly if you cool it down, then the material that will be formed will be very hard but brittle. So since it carries a glass-like character, so we call that as a vitrium bond or a vitrified bond. So this is a vitrified bond. Okay. Now this vitrified bond has got a controllable porosity. It has a controllable porosity. It has high thermal stability. It has high thermal stability. It has high refractoriness, and it is chemically inert towards any external coolant or cutting fluids. So this V bond is the bond that is used for almost 75% of the grinding wheels. Okay. So this V bond is generally used for high amount of material removal. So if you want high amount of material removal, then you will use vitrified bond in the grinding wheel. But since this vitrified bond is carrying a character that is similar to glass, that is hard and brittle, so therefore this V bond must not be used. V bond must not be used for high speed grinding. Now, why is it so? Because at high speed, the influence of centrifugal force will be high,
Yeah.
and since the bond is hard but brittle, it may break. So V bond, being hard but brittle, may break, and that can be a precarious situation for the machinist present out there. So we don't want the grinding wheel to break off at a very high speed. But since V bond is hard but brittle, so it may fail under the influence of centrifugal force. Okay. So if you want to go for a high material removal, you will certainly use V bond. Then let me tell you the importance of rubber bond. See, rubber bond is a soft bond. So since it is a soft bond, it is flexible. It is a flexible wheels. It's for flexible wheels. So it's used for polishing and distillates are taken together and heated, baked in furnace, or we can say heated in furnace at 150 degree Celsius for several hours. Whereas when we take silicate bond, we bake it in 200 degrees Celsius for several days. So here the shellac bond formation is a bit easier and quicker. So it is represented by the letter E, and this shellac bond is used for machining, is used for finishing hardened steel, cast iron, chilled iron, aluminium piston, etc. So this shellac bond is generally used for finishing operations, and it is made from plant and petroleum distillates. It provides high surface finish. It is heated at 150 degrees Celsius in a furnace and for several hours. And then it is used for materials like hardened steel, cast iron, chilled iron, aluminium piston, and for that matter, it can be also used for grinding on camps, grinding on camps. Okay, so these are the significance of the shellac bond. Now let's move ahead and discuss the resinoid bond. So right here, resinoid bond. So this resinoid bond is actually made from compounds like bakelite. So therefore, I've used the word letter B here. It is represented by the letter B. So this resinoid bond are made from synthetic resins, such as bakelite. Okay, and this resin bond is used for dressing castings. Okay, so it is used for dressings, castings, and it is used in foundries. It is used in foundries for dressing purpose in the castings. We know what is dressing. Okay, we have seen that in the case of hardness of the wheel. So dressing basically means to remove the worn out abrasives from the grinding wheel after they become worn out due to regular rubbing action. Okay, so now this resinoid bond is again heated at a temperature of 150 degree Celsius, okay, in a particular mold, and then when it is heated at that high temperature, then it gets those character of toughness, and it has that level of hardness and wear resistance. So this are the bonds that we have discussed so far. So starting from V bond, which is the most popular bond, and generally in all the questions you will find the last letter as V, because at most 75% of the grinding wheel are using it as the most prominent bond. The only thing is that we should not use it for the high speed machining. Then we have rubber bond, then we have silicate bond, then we have shellac bond, then we have resinoid bond. So these are the five important bonds. Along with that, we can also use metal as the bonds. We can use various alloys as the bond materials. Okay, so but these five bonds are very important. Okay, so now let us move for a question and see how the question can be solved by the grinding wheel specification. So the question says here, this is the question from our workbook, and this question says
डायरेक्ट लागना तो
grinding
क्या
wheel.
दिक्कत है
I'll write the question here. Grinding wheel, that is A27 K7B, is specified for finish grinding. Okay, and then of a high speed steel has to be fine or very fine. So if we look at the grain size number and the grain size, so 10 to 24 and 30 to 60. This 10 to 24 is for coarse grains and 30 to 60 is for medium grains. So now when we see 27 in the question, it lies well in this particular range of coarse and medium grains, and this coarse and medium grains are used for rough grinding, and here we want finish grinding. So since we want finish grinding, this 27 as the grain size number is incorrect. So our answer will be no, grain size is not correct. Okay, so you have understood that the specification is very very important to choose. So you have to choose the specification, being the machinist in the workshop. So therefore you have to be careful about that. So let's go for question number 13 now. It says that the base of brass bracket, the base of brass bracket has to be rough ground, has to be rough ground to remove unevenness, and we have four wheels. Four wheels are mentioned. So the appropriate wheel is, the appropriate wheel is, so option A, we have A30, K12V, option B, C90M, 4B, option C, C30Q12B, and option D, C50G8V. Okay, so first of all we have to identify the workpiece. So workpiece is brass. So this brass workpiece can be machined by Al2O3. So this Al2O3 is used for medium workpiece. It can be used for ferrous workpiece. So brass is a medium level hardness. So since it has a medium level hardness, then the hardness of the wheel, the hardness of the wheel must be between I to P, because the medium level hardness workpiece will use medium wheels, neither soft nor hard. So medium wheels will have a range of I to P as its grain. तो यहाँ पर आप देखो कि I to P के बीच में क्या लाई करता है, K लाई करता है. ओके, ये Q तो लाई करता नहीं है, इसे काट दो. ये G भी लाई नहीं करता, इसे भी काट दो. ठीक है, तो आपको ये दिख रहा है कि मीडियम लेवल हार्डनेस चाहिए अपने को. ओके, तो हम ऑप्शन ए की तरफ देखते हैं. Al2O3 ए सेटिस्फाई कर रहा है और K सेटिस्फाई कर रहा है. तो मैंने बोला था आपको कि फर्स्ट और थर्ड जो कैरेक्टर है वो सेटिस्फाई या सिंक्रोनाइजेशन में होने चाहिए. अब देखते हैं रफ ग्राइंडिंग. तो रफ ग्राइंडिंग के केस में ग्रेन साइज क्या होना चाहिए? तो ग्रेन साइज रफ ग्राइंडिंग के केस में होना चाहिए कोर्स और मीडियम. तो कोर्स और मीडियम कब होगा? जब आपका 10 से लेकर 60 के बीच में ये ग्रेन साइज नंबर लाई करेगा. ठीक है, तो हमने अभी देखा 10 to 24 कोर्स ग्रेन्स के लिए और 30 to 60 मीडियम ग्रेन्स के लिए. तो यहाँ पर 30 is lying well within the range. Okay, so this rough grinding is for coarse and medium, और यहाँ पर जो 30 है that is the medium grains. So 30 is medium grains, and yes, it satisfies the range of the grain size for which roughing is to be operated. So now then we go for the structure. तो स्ट्रक्चर पे जाते हैं. स्ट्रक्चर रफ ग्राइंडिंग में कैसा होना चाहिए था? मैंने बताया था आपको कि रफ ग्राइंडिंग में होना चाहिए था ओपन स्ट्रक्चर. तो ओपन स्ट्रक्चर कब होगा? जब आप 8 से 16 के बीच में आपका स्ट्रक्चर नंबर होगा. तो स्ट्रक्चर नंबर